All right, class. So today we're gonna look at our first lab using the Labvolt benches here. Now the Labvolt benches themselves, we're gonna get into Lab 1-1 in the next video. But if I were to give just a brief overview of what we have to look at on the Labvolt bench, they come with a power supply. Now that power supply is fed from our lab supply, our AC supply here via a breaker. Okay, it is a three-phase. What we mean by three-phase is it has three line conductors, or three conductors that have a potential greater than 0, I guess we should say. Then they have their own independent neutral, or a center point. This will make a lot more sense when we get into AC circuits. Okay, so we've got a line 1, a line 2, and a line 3, plus a neutral. So that's our three-phase power supply coming in. Now, in your households, we only ever have a single phase typically, unless you live in an area that has a commercial shop or a farm or something like that. But typically our households only have a single phase circuit, meaning that they have a line 1, that's usually your black or your red. A line 2 would be the other black or red, and then a neutral. So that would allow us from the line to neutral to get 120 volts, kind of like if you're plugging your lamp in or your cell phone charger or something like that. Okay. Or if you're going to connect up a load that you require 240 volts to. Nowadays, the most common ones would be your ovens or your stoves, ranges. Okay, your dryer would be another 240 volt connected load. And then the last one, more common nowadays, because of the way that our society is going into a greener environment, we would be looking at our car chargers. A lot of car chargers for your smart cars, your Teslas and Chevy Volts and things like that, they are connected up via a 240 volt source as well. Okay, so that's single phase circuits, and then obviously we also have the ability to create a DC circuit out of this as well, okay, because we have a DC supply that comes off of our input voltage. So that's our power supply. I've got a main volume knob, basically. We call this a power stat or a big rheostat. So this adjusts the amount of resistance coming from the power supply added to the circuit to dictate how much voltage output we're going to get. So that would be the main function of there. Okay, we've got a main on-off switch there. That would be our three-phase breaker, or a three-pole breaker. It's a 15 amp three-pole breaker, meaning each individual line is only capable of safely handling up to 15 amps. Anything greater than that, and that breaker should trip. Okay, we have a meter up here. That's a voltmeter that would output, based on the selector switch, what voltage is being applied to that circuit based on the way that I turn that knob up and down. And then we have a variety of different terminals down here. Now the first one here is a fixed AC, meaning the minute I turn that breaker on, we have 120 volts at that line conductor, 120 volts at this line conductor. I'm just going to zoom in a little bit. Sorry for the pen in your face there. We'll go down a little bit there. So 120 volts out of each of these terminals, and the neutral would be the return path for current to flow on this circuit, kind of like the negative in a DC system. Okay. Now, next to that, terminals 4, 5, and 6 are the variable AC supply, meaning they're controlled via this knob. Okay, so we always utilize that in the lab space because I like my students and myself to have control over what we have going on. So at any given point, we could adjust this terminal 4 to say 40 volts or 50 volts or 75 volts up to a maximum of roughly 120. Okay, and then over here at 7 and 8, these are our DC supplies. So this is 7 to N is a variable DC. Meaning we have control of that DC via that power stat again, and then 8 to N, or the positive 8 to the negative N, would be our fixed DC, meaning it's the minute I turn that breaker on, that's going to have a 120 volt supply coming out of it right off the bat. Other items you're going to see on here, I'm just looking at what you can focus on here. We've got a single phase to like a 3-phase to single phase 3-wire converter transformer up here. We've got a variety of different loads within here that you'll learn about in your levels of training. This year we're just going to be focusing on resistance, so that's your resistors there. Okay, we have capacitor banks there and we have inductor banks there. No need to get into the intricacies of those. Down below we have all of our meters. We've got AC ammeters here and AC voltmeters over there with different ranges and scales that they're capable of handling. We have DC volt ammeter banks, one on each side, and then above it, way up here, I'll just zoom out a little bit so we can see everything. Okay, we've got 6 light bulbs. Okay, obviously we can unscrew these and change them. These are all incandescent light bulbs. Our labs at BCIT still require us to use the incandescent light bulbs because they have a good amount of resistance with them. Okay, probably one of the few places we're going to see a lot of incandescent bulbs in the future. The next in behind there would be these 3 heaters up top there. Those are something that we call cone heaters. Cone heaters used to be something that was used in industry a lot to keep the inside of cabinets warm out in an environment where we were concerned about moisture buildup or freezing and frost and things like that. You know, a lot of communications, boxes that are sitting on the sidewalks, outdoors and things, they might have cone heaters inside there just to keep a warm ambient temperature in there to prevent corrosion from occurring on the terminals of the connections inside there, making sure we still have good solid cable and internet and whatever else feeding us. Okay, those would be common applications for those cone heaters. Outside of that, commercial applications would be maybe situations in industry where you're worried about the amount of moisture inside a motor control center or something like that because of the environment it's in. They might have those installed in the cabinet as well to keep it warm. Okay, basically all it is a little heater. 660 watts of heat coming out of there at 120 volts. Okay, so that basically gives you a rundown of what the Labvolt power supply looks like and the bench does, and then from here we'll move into the certain labs as we go forward. Okay.